This is lesson 11 about trig limits, or limits with trigonometric functions in them. And we're going to learn about two very special trig limits. These are the most used, so you'll need to memorize them before the end of this lesson. And the first one is the limit as x approaches 0 of sine x over x is equal to 1. The second one that is most used has cosine in it, and it's the limit as x approaches 0 of 1 minus cosine over x, and this one goes to 0. So you need to memorize these two. Now, the thing is, both of these, if you just plug in a 0, and you attempt to do them algebraically, you're going to get indeterminate form. You're going to get 0 over 0. So, and we don't really know, how do we manipulate and do all that. So what I need to see right now is just examine them graphically. So let's first just take a quick look at what sine x over x looks like in a graph. So this is kind of zoomed into it a little bit, but here it is, sine x over x in this graph. And as we approach 0 from the left, coming this direction, we can see that the limit as x approaches 0 from the left, it's approaching this spot right up here. And as we approach from the right, as limit as x approaches 0, it says a little positive, so from the right, it also approaches this number here, which is the number 1. So we can see it visually. We can't really, at this point in time, attempt it algebraically, but we can see it visually. And with this limit with the cosine, it's the same thing. Here's the graph of it, and as we approach from this side, as we approach from the left, the function is approaching this point right here, which is 0. And as we approach from the right, same thing. It's coming down this way, and it's approaching it to 0. So again, neither one of these are proofs, but they are just kind of confirmation, visual confirmation that, yes, indeed, the left-hand limit and the right-hand limit do approach either 0 for this one or 1 for the one with sine in it. And we need them to help us with other trig limits, and later on in the course we'll be able to find those algebraically, but we need a few other skills before we can do it. So right now it's just we had the visual confirmation. We know that the left and the right limits equal the same thing, and so therefore the limit exists, and the limit for the one with sine in it was 1, and the limit for the one with cosine is 0. So let's see how we're going to use it. Well, we're going to be using it because we're going to be manipulating, or like I like to say, is we're going to play in the sandbox with our trigonometric expressions. So here's our first example. And in this example, we've got tan x over x. First thing we do is we try to plug in the limit. So we plug in 0 to see what happens. When we plug it in, we get the indeterminate form of 0 over 0. So we know we can't just plug it in. So we're going to look at ways to manipulate this, and we realize that I have an identity that tangent is sine over cosine, and this fraction now, and I saw that the limit as x approaches 0 of this, well, this is the same thing as sine x over x times cosine. And if you don't remember that, remember that this piece right here, sine over cosine over x, is the same thing as sine over cosine times 1 over x. Okay? So I have this, and I can break this up into a product right here of sine x over x times 1 over cosine. So I have the limit of a product, and the limit of a product is the product of the limits. So I broke it up into the two limits that are being multiplied together. And now we have our special trig limit right here that we know equals 1. And this one here, we can plug in the 0 into cosine, and cosine of 0 is 1, so we get 1 over 1, which is just 1. We're multiplying those two together, and that equals 1. And so now we're going to make our statement. And our statement is the limit as x approaches 0 of tan x over x equals 1. So we write our statement right here, this conclusion, and all of that is based on this work that we have done over here. Caution at this time. Things when we're manipulating and playing in the sandbox, this is a very common error, and that is that sine of something, some number, some constant times x does not equal that constant times sine of x. This means we're multiplying an angle. This means you're multiplying a ratio. You can't do that. You cannot pull that out. Meaning, if you had sine of 4x, it does not equal, does not equal 4 times the sine of x. Just don't, that's a very, very common mistake. So I want to bring it to your attention. Don't do that. So we're next ready for our second example. And this second example, this follows with what I was talking about with this caution here. We have sine of 4x. And we're looking at this. We plugged in the 0, and we got our indeterminate form of 0 over 0. So, what can we do? If only this angle, which we see as 4x, were the same as this denominator, if that said 4x. Because if this angle and its denominator were the same thing, it's not that they both have to be x, it's that they have to be the same thing. If they were the same thing, we could use our known trig limit. So we manipulate this by multiplying numerator and denominator by 4. And when I do that, my denominator will become 4x, and we will have the following. We will have 4 times sine of 4x, because I just put that 4 in front there, because we're just multiplying that whole phrase times 4. And this x times 4 gives me 4x. Now, this angle is 4x, and this denominator is 4x. And I'm going to take this 4 and bring it out in front, because that's one of our identities. So to make it seem a little bit clearer, we're going to take this 4x and we're going to call 4x theta. So wherever I see 4x, I'll write it as theta. And if x were to equal 0, because we're thinking about when x goes to 0, theta would also be going to 0. And we're thinking about that for this part of it with this limit. So we can now write it with thetas instead of x's, so it looks more like our limit of trig, the trig limit that we learned about sine. We're going to pull that 4 out in front. And so now this, we know, is just 1, because the limit as the angle goes to 0 of sine of the angle divided by the number for the angle, that this equals 1. So we're going to have 4 times 1, which is just 4. And now we make our final statement, which is, we want to write it nice and clear and neatly, that this is what we're saying, and this is the justification for it. We have another example. In this case, we have a fraction, and we could break this fraction up. But the first thing we have to do first thing always is plug in the 0 and see what we get. We plug in that 0, we get the indeterminate form. Now that means we can break up that subtraction in the numerator, because everything is being divided by x cosine of x. So now I have 2 fractions. So I have the limit of a difference, which means I can break that up into the difference of the 2 limits. And this right here, well, that's 1. I have the limit of as x goes to 0, but this inside, x cosine of x divided, that's going to be 1. Over here, I took sine x over x cosine x, broke it up into the product, like we did before, and I now have this limit statement. We know what this one is, that this is going to be a 1 because of that one we've memorized now. This is the limit of a constant is just the constant, so this is going to be 1. When you have a limit of a constant, you just get the constant. This one's going to be 1, and this one we can plug in the 0, and that's going to be 1. So we're going to have 1 minus 1 times 1, which is just 0. And so my statement is the limit of this expression equals 0. And this is the statement, this is the justification. Our last example, example 4, this one's a little bit different. It doesn't say x goes to 0. It says x goes to pi over 4. First thing we do is we plug in the pi over 4 and see what happens. When we plug in pi over 4, we get that this goes towards 0 over 0. It's indeterminate. So we're going to have to do something. First thing I see is I've got tangent, so I rewrite tangent using the identity sine over cosine. I see fraction within a fraction, so I want to clear this fraction out. I look at all the denominators, and the only denominator that I see is cosine of x, because this has a denominator of 1, this has a denominator of 1, and this has a denominator of cosine of x. So I'm going to multiply both numerator and denominator by that common denominator of cosine of x. And when I distribute cosine of x to the 1 and cosine of x to this fraction, we end up with this new numerator of cosine x minus sine of x. In the denominator, I just left it in their products. I didn't actually distribute. I just left it that way. Because right now I'm saying, oh look, you've got sine minus cosine, and here you've got cosine minus sine. Same two things, but the order of subtraction is different. So this numerator, I'm going to factor out a -1, and that allowed me to change the order of the subtraction. So now both numerator and denominator have the same factor of sine x minus cosine of x. So I can cancel that out, and I'm left with -1 over cosine of x. And at this point, I can plug in pi over 4 and evaluate, and I end up with -1 over root 2 over 2. Remember, this means the reciprocal of this, so I'm going to have -2 over root 2, and that simplifies, and you might have to do that on a piece of scratch paper to remind yourself that 2 over root 2 is square root of 2. So we have the answer of -square root of 2. And so I write my statement, and this is the statement, and this is the justification. And that's the end of Lesson 11, the beginning work that we're going to do of trig and limits.